A good day to all the Neet aspirants of the year 2020. Welcome to a new session of the Ncore Neet mock test conducted by Imprints organization of Calicut Medical College. I am A.R. Andhagushan, first year MBBS student, Calicut Medical College. The topic today is topic 14. From physics we have waves, from chemistry we have environmental chemistry, and from biology we have respiration in plants. So let's look at some questions from each of these topics. Let us start with physics. Let us look at the first question. The question is, two cars A and B approach from opposite sides as shown in the figure. The observer hears no beats. If the frequency of the horn of the car B is 504 Hz, the frequency of the horn of the car A will be, the options are, option A 529.2 Hz, option B 295.2 Hz, option C 440.5 Hz, option D 259.2 Hz. Now let us look at the solution. This question is based on the principle of the Doppler effect. From the figure, it is shown that the source of sound is shown as S and the observer is shown as O. The velocity of the source is V, the velocity of the observer is V0, and the velocity of sound is Vs. Now let us go on to the Doppler equation. For sound waves, if V be the velocity of sound in the given medium, Vs the velocity of the source relative to the medium, and Vo the velocity of the observer relative to the medium, then the observed frequency is given by mu is equal to mu0 into V plus or minus V0 divided by V plus or minus Vs. Here mu0 is the true frequency. In the formula given above, Vs and V0 are taken with negative sign if the motion is along the direction SO, and positive if the motion is along the direction OS. From the Doppler's effect, the apparent change in the frequency of a wave that is perceived by a stationary observer is calculated by the equation n dash is equal to n0 into V divided by V minus Vs, where V is the velocity of sound, Vs is the velocity of the source, n dash is the apparent frequency, and n0 is the true frequency. Since the observer is not hearing any beats, the apparent frequency of the two cars should be equal. So by looking into the equation, we get n dash is equal to n double dash. So substituting the values, 504 into V divided by V minus 30 is equal to n into V by V minus 15. Here n is the frequency of the car A. So n is equal to, by doing the calculations, we get n is equal to 529.2 Hz. From the waves chapter, we can expect only a few questions in the NEET exam. The important topics in this chapter are the plane progressive wave, energy of wave motion, speed of transverse wave on a string, wave intensity, reflection and refraction of waves, beats, standing waves, transverse stationary waves in a stretched string, sonometer, vibrations of organ pipe, end correction, resonance tube, and Doppler effect. Now let us see questions from chemistry. Let us see the first question. Which one of the following statements regarding photochemical smoke is not correct? Option A, Carbon monoxide does not play any role in photochemical smoke formation. Option B. Photochemical smoke is oxidizing agent in character. Option C. Photochemical smoke is formed through photochemical reaction involving solar energy. And option D. Photochemical smoke causes irritation in eyes and throat. The answer is option A. This question is based on NCERT statement. So let us see. The photochemical smoke is formed in warm and sunny climate during daytime by the action of sunlight on primary pollutants. It contains nitrogen oxides, ozone, PAN, etc., which are oxidizing in nature. So, photochemical smoke is an oxidizing agent in character and it causes irritations in the eyes and throat. Now let's move on to the second question. 5-liter aqueous solution is kept in presence of oxygen and suitable microorganisms for 5 days at 20 degrees Celsius. If the oxygen consumed is 0.2 gram, the BOD value of the sample is option A 4 ppm, option B 0.4 milligram per liter, option C 40 ppm, and option D 20 milligram per liter. The answer is option C. Now let us see the solution to this question. Water pollution is measured by BOD or biochemical oxygen demand. It is a standardized measurement for the amount of oxygen required by microorganisms to cause the decomposition of organic matter over a period of 5 days at 20 degrees Celsius. BOD is calculated as weight of oxygen in milligrams divided by volume of water sample in liters. Given the weight of oxygen equal to 0.2 grams, which is 200 milligram. The volume of the solution is 5 liters. So the biochemical oxygen demand is 200 divided by 5, that is 40 milligram per liter or 40 ppm. Environmental chemistry is a relatively easy topic. The important topics that are to be studied in this chapter are layers of atmosphere, air pollutants, smoke, ozone, international standards of drinking water, eutrophication, BOD and DO. Now let us move on to biology. The questions from biology are mostly based on NCERT statements, so the students should be careful to be thorough with the NCERT textbook. The first question. Protein is used as a respiratory substrate only when option A. Carbohydrates are absent, option B. Fats are absent, option C. Both carbohydrates and fats are exhausted, and option D. Fats and carbohydrates are abundant. The answer to this question is option C. This answer is evident from the fact that the body uses carbohydrates, fats and proteins in the following order. That is, first carbohydrates are used, then fats, and only last comes the proteins. Now let us see question 2. During which stage in the complete oxidation of glucose are the greatest number of ATP molecules formed from ADP? Option A. Conversion of pyruvic acid to acetyl coenzyme A. Option B. Electron transport chain. Option C. Glycolysis. Option D. Krebs cycle. The answer is option D, as in Krebs cycle the maximum amount of NADH2 and FADH2 molecules are formed. Now coming to the last question. Which of the following is involved in the catalysis of the link reaction during aerobic respiration? Option A. Vitamin A. Option B. Vitamin B1. Option C. Vitamin B6. And option D. Vitamin K. The answer is option B. Vitamin B1. That brings us to the end of this video. Thank you for listening so patiently, and I wish all of you all the very best in your coming exams.